We welcome you here at the Technical Forum at the Group Exhibit Hydrogen and Fuel Cells 2013. You are invited to listen to the next presentation and ask some questions at the end. Here, come on, please have a seat and enjoy here with us the next presentation by Air Liquide Germany, by the Sales Director Warren Brower, dealing with the topic Complete Fuel Cell Fleet Services for Material Handling Operations. Here we go. Give me some big hand for Mr. Warren.
Thank you very much. Thank you for having me here today. Appreciate it. The slides I'm about to present, we're going to talk a little bit about some commercial opportunities and how the commercialization of fuel cells within material handling has taken off in other parts of the world, and our focus here in Europe, UK, surrounding areas to try and bring some of this technology into a true life application. As stated, my name is Warren Brower. I'm currently the sales director of a new organization called HyPulsion. HyPulsion is a joint venture that was signed into existence this past year between the cooperation of two companies, Air Liquide, which again, many of you already know about Air Liquide, so I'm not going to spend too much time on them, and Plug Power, who is a manufacturer and designer of the fuel cell products that I'm going to be talking about. So very quickly, we're just going to talk a little bit about the companies as to who we are, why we're here, what our mission is, the products associated with fuel cells and hydrogen in material handling, the benefits of those products in these market segments, the reason why these customers are choosing to deploy these products, the solution, the combination of hydrogen on-site indoor refueling as well as the use of fuel cells in these applications, and the results. What has it yielded so far in other parts of the world, and our hopes that it will yield here. So the company's Plug Power. I've been with Plug Power for several years. They began back in the late 90s. They're headquartered in upstate New York, just outside Albany, New York, which is about 2.5 to 3 hours north of Manhattan, New York City. They have about 150 employees. This includes engineering, support staff, as well as manufacturing. So the manufacturing of these products does take place in New York and currently are being shipped here to Europe. However, some assembly and manufacturing will begin to take place within the next calendar year. Also, I want to make note, and I'm going to be stressing this throughout this presentation, and hopefully this is going to create some dialogue with us after the fact. But the products that I'm going to be talking about are not research and development products. And we've heard a lot about material handling, fuel cells within material handling, hydrogen to work in material handling field. But I'm going to be talking about actual commercial products that are in use. And there are over 4,000 of these products in use every single day with some of the largest companies in the world. And we've collected over 15 million hours of operating hours on these products in the last couple of years. So what we're going to be talking about is actual products being used every day and the benefits that they bring to the customer base. Air Liquide, again, most of you already know, in 2012, revenues just north of 15 billion euro. They're present in over 80 countries, over 50,000 employees. And their focus has been, as again, most of you know, and I'm not going to go into great detail on this, and please invite you to go to their booth at C56 and 58 to be able to speak to them a little bit more about this. But their focus in technology over the last couple of years and growing specific market segments has led them into this joint venture to work with Plug Power. While in the U.S. and while working with Plug Power, I worked very closely with Air Liquide on several installations in large companies. So in March of last year, the two companies decided to come together, signed into existence HyPulsion, led by Luc Vendeval, who is the managing director. It's part of the Air Liquide group. Myself and Adrian Corliss came by way of the U.S. with Plug Power on assignment over the next couple of years to get the joint venture established, as well as work with the lift truck manufacturers, the OEMs, understand the applications here. And over the past year, we've done a lot of the business development in and throughout Europe to understand exactly where the market segments are, where this product is going to work, how we can CE certify the products that are in existence, bring them to Europe, and start adding value to the operations here in Europe. The products we represent are known as GenDrive. These are all-encompassing fuel cells, onboard hydrogen containment, water management, power management, but generally we refer to them as an engine in a box. So they are used in electric lift trucks. And earlier in the public forum, there was some discussions on some products that are focused on LP or diesel markets. Now, our focus has been and remains on electric markets with large applications, large fleet size, where they change batteries, so multiple shift type applications. So they permanently replace the lead acid battery, which has been used for many, many years within this market segment. Most applications require multiple batteries in order to meet the requirements of the application. One battery is being used for the movement of goods, a second battery is being charged, and possibly a third battery is cooling. So if you have a 3-shift operation, you require 2 to 3 batteries for every lift truck in this application. This is a direct replacement. One product is designated directly to a truck. It stays in that truck. It is even maintained in that truck. It is fueled in that truck by operators, and it reduces the amount of time required for the handling, the charging, the maintaining of batteries. It reduces and eliminates this floor space and area required for the handling, maintaining, and storage and charging of these batteries, and stays right within the truck. They can be refueled, as again most people already know and has been discussed in other forums, in as little as 1 minute, maximum of 3 minutes. This reduces a 10 to 20 minute battery swap and allows a customer to recapture the time and the labor associated with the handling of these batteries. The product itself, in many cases, can run 1.5, almost 2 times as long as an average lead acid battery, and has twice the life expectancy. Our GenDrive is a hybridized DC power source. So we use a Ballard fuel stack currently within our product, along with a lithium-ion power source or energy storage system. The reason why we do this is because it helps to maximize the output and performance of our product, because we work in very dynamic applications. But secondly, it also helps to dampen on each of the major components the overall load of it, so the life expectancy of these components is elongated. So you get to have the benefit of the power, as well as have, with the lithium ion, you have a source to absorb any residual energy that comes back through the system, as well as make sure that the life expectancy of these components is elongated. We have a 2-system platform approach to 2 specific platforms, a high power platform and a low power platform. Now what the difference is between that is there are many different trucks. If those of you are not familiar with material handling, it's too long of a topic and discussion to talk about today, but there are large counterbalance type products that are used in specific applications, narrow aisle reach trucks that can reach 30, 40 feet in the air. You have low-level order picking trucks, tugging applications, a wide variety. So we have a couple of platforms that allows us to address these market needs and the power requirements, the weight requirements, and be able to share componentry across multiple lines. This helps drive costs of the product down and reliability of the product up. Essentially, for a high power platform, we have a unique or individual casting. Now this particular casting is very, very important for a couple of reasons. Now in these marketplaces, in these applications, these trucks are moving very heavy goods. So we need to make sure that all minimum weight requirements for the truck are met. It's replacing a very large lead acid battery. Now part of what that battery does is provides counterweight. The truck is tuned to a certain braking distance because of the weight that's in it. It needs a specific center of gravity. So this casting that is used here within the system helps to address all of those needs. The second thing it does is it encapsulates the hydrogen storage vessel. So the tank itself, a high pressure tank, the 350 bar tank, sits inside this casting, providing a little additional support as well as protection to that casting. To that vessel. Then on the casting, we put basically the engine, fuel cell stack, water management, lithium-ion battery, air management, controllers, etc. Depending on what type of truck and what specific configuration it's going into, then is married with obviously the skins on the outside, which gives you all of the necessary information, how much weight to make sure that it's going in the right truck, service dates, fueling protocol, etc. On the low power platform, again, we have multiple looks at this and multiple configurations. Because of the applications themselves are so dynamic, we need to be able to address referred to as a low-level order picking or a stop-go light application, or a heavy, high-throughput tugging application, as you see in heavy manufacturing. So we have a single or a dual power module approach. Single module, obviously, an air-cooled stack. Here goes into the system. The system is used for a stop-go lighter application. But then the flexibility to add a second stack, even to an existing product, when used in a larger or more dynamic application. So what does this mean from a commercial standpoint? Now, again, as I mentioned, and I'll mention again, there are thousands of these units in use every day in other parts of the world. What we've done is we've taken a look at the requirements here in Europe and UK. We need CE certification. We need to meet certain requirements. The trucks are a bit different. The applications are a bit different. This past year, we've released several configurations of product that are currently being demonstrated and qualified by our OEM partners. And we have a vision of the roadmap over the next several months. By the end of this year, we'll have over 9 products with multiple configurations of each product to be able to offer into a real world, real environment to real customers. Anything from, as I mentioned, low-level order picking, small truck, ride-on product, all the way up to large 80-volt high-power product capable of lifting several tons. So the benefits. Where do we look? What benefit does a product like this bring from a commercial standpoint? And earlier today and throughout this show, I've been listening to a lot of the discussions around fuel cell and hydrogen in material handling and other market segments. But the reality is there are multiple segments within material handling that have a very good value proposition, make very good business sense. We all eat, we all go to grocery stores, high throughput food distribution, grocery stores. So we go in, we want to make sure that the products are on the shelves. Well, how do they get on the shelves? Well, each of these supermarkets have large distribution centers that help to support them to ensure that at any time you have food on the shelf. So in these distribution centers, generally there's 100 to 300 trucks in a captive audience in one facility that are running, if not 24 hours a day, usually close to 24 hours a day, made up again of high-level reach, order-picking trucks. These type of distribution centers have high labor costs, high energy costs, and as I mentioned, often run 2 to 3 shifts a day. Now, if it takes you 10 minutes to change a battery and 3 minutes to refuel a fuel cell, the recapture of that labor cost, you take that, you multiply by 100 people twice a day, annualize that number, and add to it a 20, 25 euro an hour labor rate. And if you're responsible for this application, you could have unproductive time equaling 20 to 30,000 hours, 30,000 man hours a year, unaccounted for. So the recapture of that time is a big value add to these customers. Same thing in the retail distribution center. You go to buy clothes, you go buy do-it-yourself, home goods stores, and then of course manufacturing facilities. Manufacturing facilities have just-in-time manufacturing. They require their trucks to move at a certain pace at a certain time, usually 2 to 3 shifts a day, large counterbalance and tugger trucks. Now, one of the benefits that this brings, because it's more of an energy, there is no deterioration in the performance of the trucks. So we all know from using an electric drill or anything electric, if we're using a battery, the more we use it, eventually the battery begins to deplete and the performance of that product begins to slow or get worse. We either have to change the battery or we have to sit and wait for that battery to charge. What this product does is it provides constant voltage and constant performance as long as it has a gaseous hydrogen within it. So what do we bring? We bring about increased productivity. So again, the truck never slows down. It only takes a couple minutes to refill. As you'll see in a couple slides, the hydrogen dispensing is done indoors in convenient location and actually becomes part of the process flow. No more driving across a huge warehouse to be able to wait in line, change a battery. We eliminate queuing, We eliminate the need to travel the great distances to change the batteries, and the product is filled in a matter of a few minutes. So we increase the productivity. We reduce operational costs. We add additional commercial space. So the size of this platform, a little bit larger to be able to fill an entire fleet, or a room larger than the room we're in right now to house the batteries that 2/3 of the day are simply sitting in rack. And of course, reduce carbon emissions. And in certain parts of Europe and certain parts of the world, this takes on a much greater meaning and a much greater message to the customers who are using this technology. So we have a four-pronged approach. We look at what we can do with each customer. And as mentioned at other forums earlier, it is very true. This is application-specific and customer-specific. This is not going to work everywhere, but today it works in specific environments. So how can we increase their productivity? What can we do to look at their application and find ways to get them savings? How do we reduce their operational expense? How do we increase their commercial efficiency and environmental benefits? These are the things that this product brings. It's a technology-driven solution. So we sit with each one of our customers, and this process has been vetted hundreds of times. An example, and I want everyone to know that these numbers I made up a couple of days ago, they mean nothing, but the idea behind what we do from an economic standpoint is we take a look at, first, what is their application? You use lead-acid batteries, how many trucks do you use, how much is it costing you, what is your labor rate, and we look at the application to find out, first of all, will it make sense for this customer or will it not? If it doesn't make sense for the customer, we refocus on where it does. Because again, this is something that we are not forcing into the marketplace, it's being absorbed by the marketplace because it makes financial sense to them. We take a look at where are the big adders, where do they need to focus in their current application. Generally speaking, it's around the actual management, the people who are actually moving the goods. How can we make them more efficient so we can recapture their time? Then we take a look at, from there, what does it mean by implementing fuel cells? What will fuel cells and hydrogen do for your application in the exact same application, and will it yield an annual savings? Now you notice here, basically what this is going to show is the fact that at times it will be more expensive from a capital standpoint to implement a new technology. We're all aware of this. It would be more expensive to use hydrogen than electricity in many cases. We're aware of this as well. But the overall cost of ownership is reduced through the productivity gains that the product brings. So we look at these customers, we look at their organization, we look at their application, and figure out how to find that for them. From a hydrogen standpoint, again, you can see this throughout the show. And again, invite you to go take a look at some of this. Hydrogen infrastructure sits outside the building. Hydrogen is never stored inside the building. It is extremely safe. It is then piped into the building to a convenient location, part of the process flow, part of the workflow for these companies, where an operator himself, not a dedicated person who's working in a room handling batteries, an operator himself pulls up and in a matter of 3 minutes dispenses the hydrogen and is back in the workflow. Large facilities can put multiple dispensing systems in place, again, so it eliminates the need for queuing and it eliminates the need for travel across a large facility. We have a 3-step process, very simple. First thing that's connected is a data cable. The data cable does 3 things. Collects data. We have over 15 million hours of runtime operating data that we use on a daily basis to ensure the reliability of these products. It also prevents drive-away, so an operator can't jump back on the truck and drive away with hoses and connectors connected to it. And it also serves as a grounding device. A dewatering hose, because we know, again, I didn't get into it here, but those know a PEM fuel cell based product creates water during the process. We capture the water on board, and the water is then siphoned off during the refueling process. Hydrogen nozzle is attached. The hose is then dispenses hydrogen. Once the hydrogen is done, it depressurizes, goes back outside. Remove the hose, 3-step process, you're back. The entire process takes about 3 minutes. As mentioned several times, and I'm going to mention again, over 15 million hours of runtime, which is gathered on every single unit that's in operation all over the globe. We have, right now in North America, about 42 customers working over 4,000 units on a daily basis. Most of them are 24-hour-a-day operations. We average just over 8,000 fills per day. So the use of hydrogen in fuel cells happens today over 8,000 times, happens every single day. The equivalent over 4.5 metric tons of hydrogen is consumed and used every day in everyday activities and everyday applications with some of the largest customers and companies in the world. So again, this is not a vision, this is a reality. The results. The results here in North America, some of these names you're going to know, some of you are not. BMW, Walmart, Cisco Food, which is the largest industrial food provider in North America, Whole Foods, Procter & Gamble, Still, CVS Pharmacy, Mercedes-Benz. These customers, we know these companies, and these companies have embraced this technology and are using this technology. Now, my very last slide I want to point out, it may be difficult for you to see up here, but it's not just that these customers trialed these products. It's not that they just thought the economics were interesting. We vetted the economics with each and every one of these customers to ensure that it made a business sense for them. But these customers have deployed and redeployed in multiple locations. 4 different Walmarts, 9 different Cisco Foods. We're about to do a few more Krogers, Bridgestone, two different facilities, Procter & Gamble, 3. So we delivered on the product, delivered on the promise, showed an economic return, showed that it was a safe product, brought about productivity, reliability, and good service. And it made a difference to these companies to the point that they've invested and reinvested and continue to deploy these products. So that's the last slide I have. I know there's probably going to be some questions. If we can't fit it all in this forum, I will be for a little while over at booth C56 and 58. I'm happy to have some discussions with you on this. But my main point today with this is simple. We come together once a year at these forums and we discuss about the opportunities ahead of us with this type of technology and this type of approach, and maybe someday we're going to figure out how to get there. And I'm here to tell you that it's happening. It's out there. These products are being used. They're bringing value every single day. The products that we purchase, the products that we eat, it may not be a very sexy industry that we're talking about, but everything that we own, everything that we consume is moved by this equipment. And I support this approach. I hope you do. I appreciate your time. Thank you very much.
Thank you very much, Mr. Brouwer, for this impressive presentation. So, it's your words. Do you have any questions here right now? Yes.
So, hi, my name is Michel Honslaar from Waterstofnet in Belgium. I just came for the last 5 minutes. I'm not sure if I missed it or not. I see that you have deployed a lot of forklifts in the US.
Yes.
So you as a European-based company, as HyPulsion, how is the deployment? Because I know the fiscal scheme in the US is quite okay for this kind of thing. I think they get 30% discount on so this is a system. Now, how is the transition to Europe in terms of deployment and also in terms of certification?
Great question. Early in the presentation, I did show a slide that showed CE certified products on the near term. Over 9 different products with multiple configurations will be available this year for purchase and deployment. All CE certified. We spent 1 year on the business development side. We are working very closely with all the major OEMs, manufacturers, for qualification to ensure that it meets all braking distance needed requirements for the trucks. Now, you'd brought up the financial aspect, 30% tax incentive on the systems in the U.S. Early on, that was a very big part of the deployment of these products, and it's why we focused in North America. Funds were used to generate interest and deployment of product so we could reach scale from a manufacturing point. That scale has been reached. Keep in mind, a deployment of a product here is not based upon 1 or 2 or 1 or 200. It's based upon thousands. I also showed that we have a standardized 2-platform approach, so we can we can reduce the cost across all of the products that we produce and increase its reliability. So from a manufacturing standpoint, we've got to a place where the cost structure and the overall benefit to the customer is there without tax incentive or government subsidy.
Okay, thank you again. So unfortunately, we're out of time. So
I do talk a lot.
Yeah,
So.
no, it was a really, really good presentation. So if there are any questions left or you have to like to discuss anything with you, please follow Mr. Brouwer to his booth to C58. Yeah, you're
I believe
here?
so, yes.
Yeah, okay.
I'm almost positive, yes.
Yes, it's a right word. Okay, thank you. Please sit down. After a short break, we will continue with the topic recent development on advanced technologies of high temperature MEAs. Thank you very much.